in last lecture, yeah, we have done a box plot. Yeah, I have sent you the material also, even the lab. Yeah, I've given already, and then the pie chart, scatter plot. Yeah, this one, the column chart. Yeah, so I have explained this part. Yeah, yeah, about the total sum of cells. Yeah, in numeric variables of different types of the fruits. Yeah, so cells in numeric variable and fruits are in categorical variable, and counts of values single categorical variables. Yeah, so you can see this one, and the cluster column, yeah, or bar chart. Yeah, this is effective with multiple series. Yeah, one per each category of another nominal variable, and it will compare the values across all combination. Yeah, so then, yeah, this is one actually that you should show in assignment. Yeah, in the assignment, whether it is in assignment 1 or in assignment 2. Yeah, but in assignment 2 you will scrap, yeah, from the website, yeah, the data. So you will get the raw data from the website, and after that you will again manage and arrange accordingly the data to get valuable information. So then these are the examples of we can say, the comparison. Yeah, so ordinal variable edge position based comparisons. Yeah. It is actually, it changes over the time. Yeah, so these are quarter 1, quarter 2, quarter 3, quarter 4, and based on each region. Yeah, Europe. Yeah, so then you can see the color for the different colors. Yeah, for Japan, yeah, for US and for Europe. So for example, you can see, yeah, I mentioned a little bit about this part. Yeah, for example, in Southeast Asia, yeah, before, yeah, the sales of let's say one automotive or vehicle companies, yeah, in some countries, yeah, in Southeast Asia, for example, yeah, it's like Malaysia, maybe, yeah, and Thailand, yeah, Philippines, yeah, Philippines, yeah. So then you can make the comparison, yeah, or by using the available data, yeah, for example, the cells, yeah, and perform the comparison, yeah. So for each country, you can provide accordingly. Yeah, I mean the color, yeah, according to the country. Yeah. Right. So then these are also already mentioned previously, and stacked column, yeah, bar chart, and pie charts. Yeah. So then you just decide, yeah, which chart, yeah, appropriate for your data actually. So we charted the best visualization for your data that you can choose. Yeah. And after that, you explain this visualization, and yeah, on the report. That is the one. So that's why this visualization is very important, yeah, for explaining and for analyzing the data, and we can even provide the decision, yeah, or decide the important decision for the business, yeah, based on this kind of data. Yeah, so pie charts when we have a quantitative value associated with a list of nominal values or categories. So we can use pie charts to convey the proportion of each category. Yeah, so the values can be measurements associated with each category, yeah, or count of occurrences for each category. Yeah, and both the categories, yeah, and the quantities, yeah, add up to the whole. Yeah, so then as we can see here, the proportion of the total, we can say product, yeah, or maybe the produce, yeah. Yeah, so, or, yeah, because of this one, it depends on the kind of or types of the data, yeah. So you can find the appropriate chart. Yeah, these are most common pie chart mistakes, yeah. When we use on set of categories that do not make a whole, that is the common mistakes, and use on categories that overlap, yeah, overlap from one to each data. So include total in chart data. So it is also the common mistakes, yeah, when we include all, yeah, the total in chart data, because of actually we want to compare, yeah, for each data. So we don't need to include the whole, yeah, or the total data in pie chart, and use 3D breakdown, yeah, and use too many categories, yeah, like this. This is too many categories, you can say. Yeah, so then it is not suitable, yeah, by using the pie chart. And this one also, yeah, 3D breakdown is not necessary actually. So we just use the 2D breakdown is, yeah, enough, yeah, to visualize the data by using the pie chart. So you can access this information, yeah, 5 common data visualization mistakes to avoid. Then you can get the details, yeah, of this in kind of information with example for each. So then you can avoid this most common mistakes, yeah, in drawing or providing the pie charts, yeah, to visualize the data. Right. And then for the comparative pie charts, yeah, for two categorical, yeah, we can see the contrast proposition, yeah, and then as shown in figure, the following figure, yeah, the proportion of the number, yeah, of the customers in, we can say, the telecommunication company, yeah, churning or not, true or false, given whether they have international plan or not, yeah, yes or no. Yeah, so then pie chart of churn, yeah, is the category. The orange color is false, and the green color is true. Clustered stack bar chart is usually preferred, yeah, because it conveys count as well as proportion, while the comparative pie chart conveys only proportion. Yeah, so for the stack bar chart, yeah, conveys yeah, count and proportion. But comparative pie chart, yeah, only conveys the proportion. And two continuous variables, so for two numeric variables, the scatter plot is the obvious choice. Yeah, so then when you have the two numerical variables, so then you can choose the scatter plot, yeah, to visualize the data. Yeah, so this is the kind of scatter plot. Yeah, the data of total bill and, yeah, total Yeah, so then you can see like this data. This is something like outlier. So then maybe draw the attention for this part of data. So why it is not grouping in this area? So then we can check on the raw data. So what is happening actually in this data, right? So the two-dimension scatter plots, it is a standard tool to display a relation between two numeric variables. For example, y-axis equal to response and x-axis equal to suspected indicator. So we can see the R, X, and Y correlated, positively or negatively, linear, quadratic, or other. The correlation between, we can say this one as X, and Y, and then we can see the correlation between both, X and Y, whether it is positive correlation or negative correlation. So it is linear or quadratic. So then we can determine based on the data given or the visualization given here. So then whether the variance of Y, the variance of Y depends on X, and is there any outlier in this data, the scatter plot. So then we can determine based on this visualization. So this is a scatter plot with no apparent relationship, and then this is with a linear relationship, it's kinds of the data that we cannot see the pattern, so because of scatter, this one is too scatter, so we cannot see the pattern of this data, and with this one we can say there is a linear relationship between X and Y here, in this scatter plot, because of we can draw the data is actually just round, surrounding this line, so then we can see the pattern or the trend of this data. So this is a linear relationship. Is X, is Y. And this is for a quadratic relationship. So you can see the pattern here. This is the scatter data. Then you can see this is the quadratic relationship. Quadratic relationship between X and Y. So the previous one, linear relationship between X and Y. So this is the pattern. So the quadratic. Can say if linear, it's just linear, just a straight line. It is linear, whether positive or negative, depends on the visualization, the result. All right, so this is for the homostatic, for the scatter plot. We can see the relationship between X and Y. We can provide like a two straight line, linear, and the data scatter inside of this linear relationship. So we have two linear relationship or two straight line, then the data between these two lines. This is for heteroscedastic, yeah. Yeah, this is for this because of the same, yeah, the line, yeah, almost the same, yeah. I mean the distance from the beginning and the end, yeah. But in heteroscedastic, the different, yeah. And this is diverge, yeah. So you can see here, this one is the highest, yeah. I mean, if compared with the beginning here, yeah. Here is the longest, yeah, we can say. The relationship between X and Y, heteroscedastic, yeah. So then variation in Y differs, yeah, depending on the value of X, yeah, this one. Yeah, Y, for example, yeah, annual tax paid, and X is income, yeah. Example, so then annual tax paid depending on income, yeah. If the income is higher, then the tax paid, yeah, of course, will be higher elsewhere as well, yeah. So it depends on the income. It depends on the X, yeah. Y depends on the X. And then two variables for continuous, yeah, scatter plot can be fed, yeah, with lots of data, yeah, for this two variables, yeah, continuous. That's why we have to determine, yeah, the suitable, yeah, the appropriate visualization in order to display the raw data. Yeah. Otherwise, then we will get a bad appearance, yeah, or bad display like this. So then we cannot read, yeah, what does mean of this data, something like that. So we cannot get the knowledge or information from this, yeah, because of this is too bad. Then we cannot read, yeah, or we cannot see the pattern and so on. And then two continuous variables plus one categorical. So with the scatter plot of the two continuous variables and change the point color based on the values of the category. So we, with this scatter plot, yeah, we can provide, yeah, for the two continuous variables and one categorical, yeah. So example, yeah, tumor types according to cells dimension, yeah, yeah, with benign and or malignant, yeah. So the cell width and the cell height, yeah, we have to data here, and then with the color, yeah, the color represents very important in this visualization, yeah, because of it represents it means, yeah, it has a different meaning, yeah, for can say purple, yeah, or blue, yeah, benign, and for, yeah, brown or orange, yeah, malignant. So then it has a different meaning, yeah, yeah. And then there is a blue here, yeah, even inside, yeah, small, then this part blue. So by using the scatter plot, yeah, with the two, with we arrange based on the color, so then we can provide the visualization for two continuous variables plus one categorical data, right? So you can try this one, yeah, using Excel. Yeah, you can. I think I provide the data of the this tumor, yeah, or you can find, yeah, from the internet, yeah, the tumor data, yeah, tumor types according to cells dimension. Then after that, you can try to create a scatter plot, yeah, for this type of data. And then what happened with three continuous variables? Yeah, so if we have a three continuous variables, so 3D scatter plot is appropriate or suitable for this type of data. Yeah, so we can do and draw or generate a 3D scatter, three-dimension scatter plot, yeah, or a surface plot. So this is the 3D, yeah. So we have three variable here, yeah, yeah, for example. So then it will generate the 3D, yeah. So we can visualize the 3D, yeah, actually X, Y, yeah, Z, something like that. So Y, X, Z, there is a depth, yeah. So that's why we can see this visualization 3D like, yeah, actually. So like a 3D, three dimension of the scatter plot. Yeah, so then the data is inside, so it shows the relationship between X, Y, and Z, yeah, with three variables for each. Right, so then with this kind of 3D scatter plot, we can rotate, tilt, yeah, and with some others operation, yeah, in order to show or to see the details relationship, yeah, for trees. I mean the three variables here, yeah. And then we can perform the rotation and tilt as well. And what happened with more than two continuous variables? Yeah. So we can create or generate pairwise scatters plot. Yeah. So for each pair of continuous variables, make one scatter plot. Yeah. So that is the way. Or we can use color to include additional dimension of interest. Yeah. Usually dependent on the categorical variable. But then in this case, we have to be careful, yeah, with axis, and could be too much to show them all. Yeah. Yeah, so then we should consider, yeah, the display or the appearance as well. Yeah. Sometimes it will make confuse, yeah, for us. Yeah, if too many same axis, yeah, yeah, solves, yeah, then we have to again rearrange for this kind of scatter plots, yeah, or pairwise scatter plots. So then this is the one example, yeah. This bar or this color, yeah, for Cancer, yeah, with red color and blue color for normal. Yeah, for each variable here, for different variable. All right, so the next one is line chart. Yeah, line chart displays the trends of for two quantitative axes. Yeah, so two quantitative axes. One of them represent continuity. Yeah, for example, time. Yeah, so we can say the number of cases per month. Yeah, or cells also can. Yeah, or yeah, anything that represent the relationship for uh, two quantitative axes, for example. Yeah, with the This one with the different data, yeah, bears, yeah, and then dolphin and whales. Yeah, and this one is year and this is number. Yeah. So one Y value for each corresponding X value, and like a scatter plot, but connecting the dot. Yeah, so this is the difference. Yeah, we connect the dot, yeah, for each value here. Yeah, is for blue value, so we connect the dot. Yeah, and then red value we connect the dot. Yeah, and then green value also we connect the dot, yeah, for each data, yeah, or each value. And then for two continuous variables, if the data has a temporal component, be sure to exploit it in time series. Yeah, this is a example. Yeah, yeah, for the time series data for this one. Yeah, so we can see the pattern actually, or the trend. Yeah, this is steady growth. Yeah, and you can see this one in, yeah, in like a stock market. Yeah, stock market. Sometimes we can see the pattern of the graph, yeah, like this, the visualization. So then we can read here from, for example, for 1 year, 2 years, 3 years, and so on. So we can see the trend, yeah, for to predict the market price, yeah, of the stock. And then maps here, yeah, visualizing the maps are visualizing the information, having the geographical location component. Yeah, so it is a spatial data. So there is a choropleth map. Yeah, it is a thematic map that uses the numeric value for color shading. Yeah, associated with the location. This is the map. Yeah, you can see here. Yeah, mostly if we see this kind of visualization, you can see from the report that released by the, yeah, this is like renewables, a global status report, yeah, from the United Nations, for example, from World Health Organization. Yeah, so then you can see this kind of visualization representing the geographical location, yeah, based on the maps. So then put the color, yeah, for example here with the yellow, yeah, and green. Yeah. So it has a different meaning for each. Yeah, this is representing 1 to 10%, and this color representing 11 to 20%, and this color representing 51 to 60%, yeah, 71 to 80%, and 91 to 100%. So then you can see, yeah, which color in one region or one country. Yeah, one country, you can see which color appear here, and that is the meaning of the color. So the color solves the, what's it, the meaning, or it has a different meaning for each color. So for multiple maps, yeah, side by side, so we can see here how many dimensions, yeah, or variables are represented here, because so it has a different colors for each. Yeah, this is actually United States, the state level support. Yeah, yeah, for orange or opposition green on school voucher. Yeah, relative to the national average of 45%. Yeah, because so it has a different states. Yeah, these are United States of America. Yeah, so then each state has different representation. Yeah, here different values. Yeah, so then we can draw with multiple maps side by side here. So then if you want to know more about these multiple maps, you can explore on this site, the society page, the societypages.org. Then you can see and read more about this kind of visualization by using the multiple maps side by side data. And interactive maps, interactive maps, it is visualizing information on map with interactive features. Is one example, coronavirus in or 2019, COVID global cases by John Hopkins. So then this is considered as an interactive map, as interactive map here. So then you can see, you can click for each part, and you can drag and even zoom out this kind of map. Then after that you can see the data here, and the connection, the relationship, and so on. So then if you take one country, for example Malaysia here, so then you can see how many, even you can break down, can do the breakdown based on the state. Or Indonesia here, you can break down based on how many province in Indonesia. So each province has different data and different pattern, or different case. So then by using these interactive maps, we can see the smaller region, in details, for each region, of course. So then we can get information for each region. All right. And spatial temporal data, so it animates the change in time and location over a map. It is a spatial temporal data. So you can see this in YouTube, about the growth of Walmart and Sam's Club over time. We can see. We need to sign in with the YouTube here. All right, never mind. So then if you want to see more about this spatial temporal data, then you can just watch this video about the growth of Walmart and Sam's Club over time. And then time versus animation. So animation are an interesting way for demonstrating phenomenon, actually phenomenon for the data, based on the data, of course. So then it is an interesting visualization, and time variable is usually utilized to make animation, because we can easily depict the time series data. So with many variables changing over time, it may be too much information for our brains to keep track the important change. So these are some examples that we can see the time versus time variable versus the animation. Number of death in the world by cars, and then a bar chart. Race largest producer of crude oil from 95 1965 to 2017, yeah, and popular or best-selling mobile phone brands. So you can explore this data, yeah, or just explore this. There is a YouTube or a link, yeah, yeah, and then you can see, yeah, the time variables versus the animation. I'm not sure. We can check one whether it works or not. Can you see the video?
Yes, sir.
Okay. So other animation, so it is actually interactive. So then it's very interesting as we have seen on the video, yeah, on the YouTube. So it changed, yeah, for every month, yeah, every year and every month. So then we can see from the certain duration, yeah, for the richest people in the world. Other animation and the other charts, yeah. So there are many other types of chart, yeah, in Excel or and other tools, yeah, like area, surface, radar, yeah, network, yeah, graph. So then, yeah, we can see the types of chart. So like this. So it depends on our creativity actually. Yeah. So then, yeah, in order to attract the reader or in order to provide, the details of the data and pretty, easy to understand, readable information or data for the audience. And general visualization principles, it is essential to be well served. First, yeah, we will first with the data that we are visualizing actually. So then we have to find the appropriate data visualization, yeah, to to show or to generate the information for the people. Yeah, and then poor design can ruin what you are trying to convey, and maybe it will not be delivered. Yeah, so it is not delivered if we select the wrong or the bad visualization. Yeah, this is the bad examples of the data. Yeah, so then yeah, you should avoid this kind of visualization. That's why you have to find the appropriate visualization according to the available data, yeah, that you have. And then for EDA, yeah, exploratory data analysis, yeah, is useful for delving into data and examining important relationship, yeah, for association, correlation, yeah, for between the variables and also identifying the interesting subset, yeah, of the observation. Yeah, and then the context of the result communication. Yeah, so we have to see also to consider the audience. Yeah, who are your audience? Yeah, yeah. When we provide the data, yeah, by visualization, so we have to consider the audience. Yeah, whether this is for the school student or maybe for the university. Yeah, because so it will be different types of the visualization, different kinds. So then what do you need your audience to do? Yeah, so we have to consider also here, based on the visualization, audience will make the decision. Yeah. And how will you communicate this need to audience? Yeah. So it depends on the who, and it's often decided for you. And the presentation, the documentation, interactive web page, and so on. And finally, we have to know what data are available to support the story we are going to tell, or we are going to explore, and how to visualize it. And so then you can learn more, study more about this in this kind of link. So then you just click this link and you can see the report, or the articles, in order to understand the context of the communication. Right. So